All right, so today we're talking about irrational and rational numbers. I'm going to jump into this. These guys are all imaginary numbers, imaginary things anyways. You've probably, well, I don't know, some of you might actually believe in the Loch Ness Monster or leprechauns, but they're usually considered imaginary. Imaginary numbers are kind of the oddballs. They're way off to the side here. Not many things are imaginary, and anything that is, that has a little I on it. Do you remember that from last year? Like 4I. An I in your answer means that the answer was imaginary. It's impossible. Pretty much all numbers are real. See how the giant group of the numbers here is real? And of the real numbers, there's irrationals and rationals. Again, irrational is kind of the more rare. Irrational are things like pi. They are decimals that go on forever and never repeat. Don't worry about taking notes on that. What's really important here is I'm trying to show you we're talking about the rationals, which is all these guys. All the rest of them can be written as fractions. Even whole numbers can be written as fractions. 0 can be written as a fraction. All of these can be written as fractions. Okay, that's what rational numbers are. They're numbers that can be written as a fraction. All right, moving on. If you're dealing with fractions, you have to be able to reduce and cancel. We talked about this a little bit yesterday. I want to see if you caught on to it. If I have 7/21, can I reduce that? Yes. How could I reduce it? By canceling. If you learn it this way, I think it's good for you. This 21 could be 7 times 3. It's a weird 7. And this is a 7 on the top. And now see how the 7s can cancel? And the answer is 1/3. When you cancel, you're leaving a what behind? A 1. Good. So this is really 1/3. See? All right, this one. Can I cancel stuff here? Yup. And it's really subtracting, so it would be n to the what? N to the 5th. All right, next one. Can I cancel here and go doink, doink? No, not if you're canceling over adding. If there's a plus in there like that, you cannot cancel over adding like that. Can I cancel the 3 and the 6 a little bit? Do some reducing there. Yes, I can, because those guys are being multiplied, see? If the things are being multiplied, then they can cancel. But the things that are being added together can't cancel. Now, wait, just hold on, I'm not done here. I'm going to change this 6 to a 3 times 2, and this is a 3. And now I can do some canceling. Cancel, cancel. All right, so now the final answer that I would give is n plus 1 over 2 times n is 2n. Now can I cancel those n's? No. Now you want to clarify anything? Could you multiply this 3 in? Yes, you could. But if you did that, it would be harder to do the canceling thing. But you could. All right. Next kind. This one right here. Can or can't I cancel those z minus 2's? Are they being, as terms, are they being multiplied? And therefore I can cancel them. Yes, I can. If I was trying to just cancel the z, no, because then the little term is being added or subtracted. You can't do that. But you could cancel the whole thing because what's attaching it to the other thing is multiply. See? It's being attached with multiply, so I can cancel those things. Now, can I cancel some more with the 8 and the 4? Yeah, we usually call that reducing, but 8 would be 4 times 2. On the bottom, I have a 4, and then I can go cancel, cancel. Final answer is 2. All right. Over to here, we need to be good at factoring. Do you remember how to factor? You could take this puppy and make it into 2 sets of parentheses. All right, I'm going to remind you, I'll do this one for you. I'd say x, and then I'd say what multiplies to 2 and adds to 3? 2 and 1. Put a little plus and a little plus. And now I have x plus 2, x plus 1 over 4 times x plus 2. And now the x plus 2's can cancel. That needed factoring. I'm going to do a lot more factoring with you right now. So if you're worried about that, stay focused on this one. All right, this is foiling. This is where factoring comes from. If I take this and multiply it out, x times x, x squared. That's the firsts. My outside and my inside make negative 2x. My lasts make negative 8. Do you remember doing that? Foiling? Okay, good. So factoring is like unfoiling. It's like, here's the question, and what should it turn into for factors? Factors mean things that multiply together. So if I take this and make it into 2 things that multiply together, it would give you that answer. All right, so if the question was, factor this, you would go, okay, I need 2 parentheses, x and x to make my x squared. And then I got to find something that would multiply this times this to make my 8. You know, first outside, inside, lasts. My lasts need to make negative 8. How can I make negative 8? Well, 4 and 2 probably. Okay, if I put a 4 and a 2, then which of them should be negative? Because only one can be negative, otherwise I won't get negative 8. And then I can judge by this middle number and say, oh, I think I should make the bigger one negative. And then you just check it. Check it by foiling. You can. That's the cool thing about factoring is you can always check it. I do my first, x squared, my outside, 2x, my inside, minus 4x, and my last, minus 8, and I see if it really worked. X squared minus 2x minus 8. That's what I had in the first place. It worked. So it checked out. Do you get how when you factor it, you can check it like that? That's really key. All right, so moving on. Factor that. Those of you that have been kind of in your own world here, get with me again. I won't name names, but some of you didn't look totally with me. Try factoring that one. That's the way you start, always. Then you just got to ask yourself, what multiplies to 15 adds to 8? 5 and 3, plus and plus. What if I wanted to know for sure that I was right? What would I do? Yeah, just FOIL it out, multiply it out. X squared, outside 3x, inside 5x makes 8x, and the last makes 15. Yep, did it right. All right, why is factoring so important? Because, try this one. You're going to have to factor things and then do the canceling. That's kind of you're going to have big fractions that are going to involve factoring them and then canceling things. So like for instance, this one would be over the top of a different one, but first factor this one. Let's say the problem was like this. Then on the top, I think you probably could factor that, and you probably said it was minus 3 and plus 1. Is that what you said? Good. Then let's say the bottom was like this. How do you factor that? Well, what comes out of both of them? An x. What will be left once I factor that out? Take x out of both of them, you'd have an x minus 3. Now see how stuff can cancel? Cancel, cancel. What's left? X plus 1 over x. Can you cancel those or not? No. There's a plus there. All right. Any questions on that? That is a typical question that you would have on your test to be one of your easy ones. Factor this, factor that, see some stuff canceling. All right. So you are going to have to are you going to have to do this on your test? Actually, yes. There are some questions as simple as that on your test that you're going to have next Tuesday. Just plain old-fashioned, add some fractions. Okay? But if you can't handle it, the reason we're doing this, don't be insulted, please, that we're starting with adding fractions, because I have to build you up to be able to handle that, for instance. And if you can't do it with simple numbers, then you have no hope of being able to do it with this. All right? So we'll start with the simple stuff. If you're just going to add some fractions, you got to get a common denominator. 1/2 plus 5/7. What's a good denominator for those guys? 14ths. So this would be 7/14, and this would be how many 14ths? Well, you double the 7, so we double the 5, and it makes it 10. And now I can add them. And please don't ever change these to a mixed number. Leave them like that. I know improper sounds like wrong, but it's actually good. We like that better than 1 3/14. Because this, if there was a variable thrown in like a, we could just throw it right there. No big deal. But if it was 1 3/14, be like, where the heck do I put the a? You can't. You can't put it here. You can't put it there. It would mess up a lot of stuff. So don't use mixed numbers. Improper fractions are proper. Yes? I don't think you are. I'm not positive of that, but we all do our tests the same exact way, and I'm about 80% sure. I'll tell you tomorrow for sure that you're not allowed to use calcs. Because I know you probably think, well, I can just type that in the calculator. But the problem is, see, when you get to what we're going to be doing, try to type that in the calculator. You can't. Okay, so your fractions that you're going to have aren't just going to have numbers. They're going to have lots of complicated stuff in them. All right, and on this one, all I would hope that you'd know so far is, can I cancel those sin x's? No, because there's that plus there. Okay, can't cancel over adding. All right, so back to this. If I had 2/3 times 4/5, these are the easiest kind in the world. As long as you line them up right, you multiply across the top and across the bottom, and you're done. That's very simple. All right, now if I wanted to do some canceling ahead of time, like if this was a 14 and this was a 18 or something, you can do some canceling ahead of time. That makes these a little easier, but in this case, it's so simple. It'd just be 8/15, done. Just multiply across the top and the bottom. Multiplying fractions is awesome. Subtracting fractions, exactly like adding them. Let's not waste the time. Simple. Dividing fractions is so hard that I don't think you should ever do it. So instead, you should change it to what? Multiply. 3/8 times, and I can't just leave this number the same. If I'm going to change this from divide to times, then I got to change this number to what? 26. Very good. And then, do you remember that part where I said you could cancel by doing stuff like this? What have 3 and 6 both have in common? They both have a 3 in them. 3 times 2, and now cancel, cancel. See what I'm doing there? What do the 20 and the 8 both have in them? A 2, something bigger though, a 4. So a 4 times 2 and a 4 times 5. Cool part is that then it just goes cancel, cancel. And when I'm canceling, I'm really leaving behind 1s. So it's 1 times 5 is 5. Over 1 times 2 times 1 times 2. Bottom line is 2 times 2, which is 4, 5/4. Should I make that 1 and 1/4? No. Leave it as 5/4. All right, there's the basic reminder on fractions. So when we step up into the hard ones that you won't freak out. What if they're not fractions? What if it's like 2.5? Then you got to make it into a fraction. It's really not that complicated. If you want to do a fraction problem, make them all into fractions. Like this, 2.5 should be 5/2. Do you remember how to do that? You go this times this plus that. Yep. In case you forgot that, you want to make a little note for yourself. If you're already good at that, cool, but that times that plus that. So I make it 5/2. 5/2 plus 5/7. Now, can they have a common denominator? Yeah, if I make it 14ths, and then we go back to where we were. All right? This kind, 2/3 times 6. That's not a fraction. Make it a fraction. 6/1. Good. And now what? Do I have to have a common denominator to multiply them? Nope. I can just multiply it. 2 times 6 is 12 over 3. Or I could notice that this could be 3 times 2, and I could go cancel, cancel. And then my answer is just going to be 4/1. Either way, the answer is 4. All right. I'd like you to try that one. You'll take 5, you'll change it into a fraction. You'll take 2 and 1/4. That's supposed to be like this. And you'll make it into a fraction. And then you'll subtract them. You have to have a common denominator. See if we can do it. I know you've learned fractions. In fact, you probably learned them in 3rd grade or 4th grade. You were capable of doing that problem. But it's been a long time. And now we're going to do it with sine and cosine and tangent squared and things like that. All right, so you should have said 5/1. And you should have said 2 times 4 is 8 plus 1 is 9, 9/4. Can I subtract them right now? No, don't have a common denominator. How do I make them a common denominator? Probably use 4ths. 5/1, I'm going to change it to 4ths. Well, it's 4 times bigger, so 4 times 5 is 20/4 minus 9/4. And that would be 20 minus 9 is 11/4. Raise your hand if you have 11/4. Awesome. Okay. This other one, dividing. It should be easy for you. Make this into a fraction. And remember, don't divide them. Do something smarter. Try it right now. Get your pencil. You done already? Holy crap. That's fast. KV, tell me what you did.
So I did 6/1 times 20/6, and then I crossed out 6, and then I got 20.
Sweet. Raise your hand if you had that one right. Okay, good. I know some of you weren't done yet. It's not fair, but get the idea. All right. Now, I want to pause for names. So back to fractions that get tougher. This is the square root. It's not that hard. You just got to know that you can break it up into two parts. Square root of 4 over square root of 9. And what's the square root of 4? 2 over square root of 9. So yes, you can break down square roots like that. It's legal and it's good and it makes it a lot easier. Okay, this one. Remember how I said never divide? It's dividing. So change it. Everybody try it right now. See if you know what to do without any help from me. If I'm saying don't divide, I can't do 2/3 divided by 7/4 because that's what it is. Change it to times 4/7. Final answer, 8/21. Raise your hand if you had that one right. Awesome. On to the next one. Remember that factoring step we took? Like a little reminder on how to factor? It's because there's problems like that. Factor them. See what cancels. Once some stuff cancels, you'll have your answer. The top factors, the bottom factors. I can tell from people squinting that I should make that bigger, so I'll make it bigger. All right. Top, x, x. What multiplies to 1 and adds to 2? 1 and 1. On the bottom, what multiplies to 4 and adds to 5? Yes, x plus 4, x plus 1. Cancel, cancel. X plus 1 over x plus 4. Oh, and then I can cancel the x's, right? No, not allowed to do that. The final answer is x plus 1 over x plus 4. There it is. Okay, moving on. Even tougher ones. Yes, you'll have to do things like this. And I think you could handle this one as long as I tell you it's a big fraction C like this, so it's a divide. So remember, you're not going to want to divide, you're going to want to multiply. And you need one more little thing. Whenever you have fractions that have multiple parts, you want to put parentheses around anything that's not a single number. Like putting parentheses around this is just dumb because it doesn't hold anything in. Okay, it's just a single thing. No need for parentheses there. But when it's got two parts, put a parenthesis around there. It'll keep you from making a mistake. Try that one with parentheses around the top and bottom of the fraction. A lot of times people make that mistake on their ACT tests. They don't know how to put that in the calculator right. You really need to put the parentheses around it to make it work. If you try to type this in, let's say they were all numbers. You're trying to type it in the calculator. If you forget the parentheses that aren't even there, if you forget to put those parentheses in, you'll get it wrong. So you have x plus 4, y minus 2, and then you say times, and then you got to flip it, y over x squared. Well, that's a good start. How many you got that far? Okay, good. Now you actually would have to multiply it out. So y times this and y times that. I can't just pick one and stick a y on it. That's why the parentheses are good. They keep you from doing that. You realize that you got to distribute it. xy plus 4y on the top. And the same kind of thing happens on the bottom. I can't just slap this x squared on one of them. It has to go on both of them. So you'd say x squared y minus 2x squared. Excuse me. This last one here is brutal. If I asked you to do it, I betcha I'd only have one kid get it right. And yet, it's a question on your test. It's not the same answer, not the same question, but there's one like it. Watch, if I were you, I would try it, but kind of watch me do it and see which parts you could have handled yourself. All right, so if I'm going to try this one right here, I'm going to just get rid of this one. I'm going to take this one and blow it up a little bit. Okay, I would start one thing at a time. I would take the top part and see if I could do the top part of my fraction. Do you get that that is a subtracting fractions problem, really? Because if I put this over 1, does it help you to see that they're both fractions? And I need to add them together? To do that, I would need a common denominator. What's a good common denominator? If one of them has a 1 and one of them has a x minus 2, well, that's tougher. To get a common denominator there, I need to make this one here, instead of being a 1, make it be an x minus 2. If I multiply by x minus 2 there, I can multiply by x minus 2 here. See what I'm doing there? I'm getting a common denominator. Now they both have a x minus 2 in the bottom. Why can I do that on the top and bottom? Because really, I just multiplied by 1. All of that right there is equal to 1. All right, so now I'm going to multiply across the top here, and I'd have x times x is x squared minus 2x, and then I have a minus 3 here. So it's going to be x squared minus 2x minus 3 over, on the bottom, my common denominator was x minus 2. There, I just did the top of the problem. See how hard that was? It's not easy. This is kind of cruel, but this is something you're going to have to be able to do in pre-calc. Okay, can you learn it all on the second day of school and be awesome at it? Probably not. But we're trying to prepare you. This is all, it's just fractions. It's really what it is. It's just your fractions aren't going to be just nice, simple fractions anymore. This is upper level. So, anyway, moving on, this bottom part right here. First thing I told you about fractions is fractions play nice with other fractions. Right now I have to make these both into fractions. How about that x? What do? Put it over 1. And now, do they have a common denominator? No. They need a common denominator to be able to add or subtract them. So I got to make this have a denominator of x. If I put an x here, I got to put an x there. So I'm multiplying this by x over x. Now I'll have a common denominator. On the top, I'll have x squared minus 5. On the bottom, the common denominator was x. So it's an x. So now I'm just going to move that over here. And now I have a great big fraction. Here's the middle part of the fraction, and the bottom is x squared minus 5 over x. Now I have a fraction over a fraction. Now I can flip and multiply. All right, so now I can take this part. I'm going to use a new color I haven't used. I'll use black. X squared minus 2x minus 3 over x minus 2. And I'm going to times it by, flip and multiply, x over x squared minus 5. Remember that part I was saying about how you really should have parentheses that you can't even see around giant fractions? And now, to finish this, I would have to multiply all of that out. X times this, and x times this, you know, like this. And I have to do a FOIL to do this one, because see, it's got two parts. First outside, inside, last on the bottom. Yes, you actually have to do problems like that. That's why we need you to be good at the basic fractions we're throwing at you right now, because there's going to be problems like that. About as hard as it gets, though, to be honest. As far as fractions go, you won't ever see anything any harder than that. That would be the hardest fraction problem you'd ever see, except they might have a word sine thrown in there. Sine of x, sine of x, sine of x, and sine of x. Well, otherwise it acts the same way. All right. Okay, so that was a hard one, but I'm just trying to show you why you need fraction stuff, because you got to be able to do common denominators. You got to have fractions in fractions, and you got to be able to simplify stuff and know what cancels and what doesn't. All right. So let's not do any more. I think your brain might explode. There's some simpler stuff that you have to know. Finding the slope of a line. Remember how to find slope? It's a lot simpler. Got 2 points here. You just take this one minus this one, y sub 2 minus y sub 1, over x sub 2 minus x sub 1. That's the little formula. But in case you don't remember that, you just go, the y subtracted, this one minus this one, negative 2 minus 2, over that one minus that one, 4 minus negative 1. Final answer, negative 4 over 4 minus minus 1 really means 4 plus 1, and that means 5. Negative 4/5. That's the slope. You've been finding slope since 8th grade. Now, have you done it a lot lately? Probably not. That's why we're reminding you. Try it with these 2 points. See if you can find me the slope of that. And if you can, I'll tell you what the answer is in a minute, and you'll know whether or not you're good with the slope thing. Much easier because there's no negatives. So it's the y's on top, that minus that, 4 minus 1 is 3. That minus that on the bottom, 3 minus 1 is 2, 3 halves. Raise your hand if you had that one right in your head. Okay, good. To find slope on paper, all you have to do is say rise over run, right? So from here to here, how much rise? -2. How much run? 3. So the answer for the slope on that is -2/3 is what the slope is on that. It's the rise over the run. All right. I think that is enough. If they give you 2 points, then you can give the slope of the line by just going, okay, 9 minus 8, 9 minus 8 is 1, over -4 minus 5. Final answer, 1 over -9. That's the slope. But they didn't ask for the slope. They asked for the equation of the line. Okay, if they want the equation of the line, then I got to go like this. Y minus y sub 1 equals m times x minus x sub 1. You guys did this last year. I know you did. It's been a while ago, but you did it. Now, this little equation, you can put the point in right here and the slope in right there, and I'll have y minus some number from a point, I'll pick one of those 2 points in a minute, equals the slope. We just figured out the slope is 1 over -9, or -1/9. And now all I have to do is take a point and put it in here and here. The point I'm going to pick is the easier one. That's the easier one, so I'm going to put in that point. The x goes here, 5, and the y goes here. It's 8. So there's your equation. All right, to help you do better on this homework, I'm going to hand it out, do the first couple with you. And we'll do like one from each section. So I think that's all I got for the video for today.